So this is the command you use to SSH into Behemoth 1. Password for Behemoth 1 is this. So cd to Behemoth ls. Okay, we have this. Let's start with Behemoth 1 and let's see what it is. Type ASDF. Sorry, authentication failure. Okay, so let's check ltrace. Ltrace this. STF. Okay, we got nothing. It's not giving us any sort of clues. So let's run Behemoth 1 again to see if there is any buffer overflow condition. Sorry, nothing. So let's try to copy this, paste it bunch of times and hit enter. So the difference between this and this is a segmentation fault, which means the program crashed. So seems like we have a buffer overflow situation here. So now let's find out where it exactly crashes, after how many bytes it crashes. So to get that, we have to use pound debugger. So we have the commands listed over here. So just copy paste it, just hit enter. Okay, now we can use pound debugger and say Behemoth 1. Just hit enter, enter. So the first thing you do is disassemble main. So we're disassembling the main function. Okay, let's see what we have. Okay, we have only tiny bit of code. So the buffer overflow is caused because of this gets function. For example, a simple buffer overflow can be caused when the code relies on the external data, receives a gets function to read data in stack buffer. So let's go back here. So how many characters is this? So probably 100 characters, right? So what we'll do is we'll just create some sort of unique pattern to identify the number of bytes of data. To do that, you have to give this cyclic command. So just say cyclic 100 and it will create this unique string. And as you can see, for every 4 bytes, it changes. So now let's copy this and use it while running the program. So run the program, paste the password and hit enter. If the program really crashed, we have to see the registers. Okay, so it says invalid address. So you have to see this EIP. EIP stands for Extended Instruction Point. So EIP is a register that holds address of the next instruction to execute. So in the context of a function, if a function returns, for example, let's say function starts here and let's say here is the code and finally we say return to something. Finally we end the function with this bracket, right? So if this function is called, the first thing that happens is it goes here and goes to the memory, executes the code, and finally there is a return function. When a function returns, it jumps to the address stored in the EIP, which is usually the return address saved on the stack. Okay, it goes to this EIP. The program finally executed and finally we got the same EIP address over here. This is the return address. So when a buffer overflow occurs and the EIP is overwritten, the control flow of the program is altered. Instead of jumping to the correct return address, the program tried to execute whatever address is overwritten by EIP, okay, which is an invalid address in this case. So to see which location this is, all you have to do is copy that and say cyclic -l and paste that string. And here you see offset at 71, right? Which means it crashed when it reached 71. And you need to understand that the cyclic pattern uses zero-based indexing, which means the counting starts from 0. The 71st position is where the pattern is ASAA, which means the first 71 characters does not cause any error. And this index starts from 0 to 70. So this is before ASAA. The EIP address is overwritten when it starts the 72nd character all the way to 75th character. So now we are going to construct a shell code. So the most effective shell code that I found out is shellcode 606. So if you Google this shellcode 606, you can find this shell storm which has 606 right here. So this executes something like this. So it will try to run a bash shell and it will keep the previous privileges. For example, if the user has some setuid permissions, it will keep that setuid permissions even after we got a new shell. So just copy paste it from here. So now this is our shell code. To create our shell code variable, we are going to export it as an environment variable. So for that we say export shell code, keep a dollar symbol and quotations, and in between the quotations keep this shell code. So usually this much is enough, but some people would like to keep some NOP sled because they don't know exactly where it's going to start or where it's going to end. So I'm going to create a C program to make the shell code execute without any NOP sled. Okay, sounds interesting. So what do we do first is just copy this, exit out of here, paste this shell code and check whether it is registered in the environment variables. So type env, and if you scroll up you can see that the shell code exists right here. Now we have the shell code environment variable ready. So the next thing we do is create a temp directory. We say mktemp-d, copy this and say chmod 777 and cd to this. And now we are here. Create a C program which I will say nano environment address.c. So I want address of this environment variable. First thing I do is hash include. So it's common. Again, hash include standard libraries.h and string.h. So now I'm going to start the main function, for which I would say argument and the pointer of argument. So I would say character pointer of the value of arguments, and I'm going to start my function, and here I would say character pointer, and the name of the pointer, let's say, is ptr. So to this pointer I'm going to give the environment variable of argument value of 1. So what this generally means is it's nothing but get environment variable location. So why argument value of 1? I'm going to create two arguments. The third argument is obviously the name of the file. To do that, argument value of 0 and argument value of 1 and 2. 0 is basically the name of the program itself or command itself, and this one is first argument of command, and this is second argument of command. What I will create is something like I will run the program and I will say first argument and second argument. So I have a space in between the arguments. So this is what I want to create basically. So usually the program is the program name itself. The name is environment address. So I'm going to create a binary for this, and I would say environment address, and the first argument I want to keep shell code itself. So the variable of the shell code is shell code, and the second argument I want to keep the program of Behemoth. I'll tell you why I want to keep it. Behemoth 1. So this is the program that I will be running, right? So let's get back to the terminal and finish the program. And to this pointer, I'd like to add the difference between the string length. So I'll say string length of argument value of 0 minus string length of argument value of 2. I would require twice of it. So what will this do? This will basically adjust the memory address for a particular program name. What did I say? It will just adjust the memory address for a particular program name. For the program name this, the memory of the shell code will adjust somehow, and finally we will get the exact shell code address so that we can execute it. We want to print, and we'll say %s will be at %p/n to create a new line, and argument value of 1, that would be the string, which is actually the variable shell code, and the pointer would give the address. Sounds cool? Just save it, Control X, Y and enter. So now we have the program. So to run the program we need the help of GCC, and we want a 32-bit version of it, and the output of this file should be like environment address, and finally give the name of the file. And it created this environment address. So this is the binary that we're looking for, and I have already created this command, right? So environment address, so I can just copy paste this thing, Control C, Control V. So basically the environment address and the shell code and the name of the program which will be running. So hit enter, and finally we got some address, and it says shell code will be at this location. Using this memory address, we want to create some program to run the shell code after it has buffer overflow. So first of all, which format is the system running this memory addresses? So to do that, you have to check which endian format this is. So to see that, ls cpu and grep that to endian. So here you can see the byte order is little endian. So little endian means it will start from the lower addresses to the higher addresses. System reads from right to left. So to create this, all I have to do is I have to say 0x this thing and 0x this thing and 0xff 0xff. So this is the address in which the shell code exists. So this is the address we want the EIP to be registered. Okay, so if you remember this EIP, so this is the address, right? So this address should be overwritten by this or this, so that we can execute shell code. Let's check if we have Perl. Okay, we have Perl. So when we have Perl, we can execute some program like Perl execute this script, and I would say print and just add some random characters. Any character would be fine, times 71, so that we have filled the buffer 71 characters, and then our shell code. So now the shell code, just append it, double quotes, this double quotes, and finally end it with semicolon and a single quote. And whatever the output is, redirect the output to /behemoth/behemoth1. So just copy this and paste it over here and send it. So it looks like the program ran, but we don't know what happened. Did it execute shell code? But we are pretty sure that this address is overwritten by the EIP, and something happened and we did not quite get the shell. So to check if we got the shell, use cat command. So cat command will keep the input stream open. So use the same command but add semicolon cat. So now just run it, and we have that input stream open. So we can now execute some commands. So let's try some random command and we get this, and let's type the random command again. So as you can see, this bash command cannot be found. Interesting. So are we in bash shell? So let's check with who am I and ID. So we are Behemoth2 and we have effective user ID of Behemoth2. So currently we are Behemoth2. So let's get the flag. So to get the flags, just find /, type file, name Behemoth2, redirect the errors to /dev/null, and finally we got the file. So let's say cat this, and we got the answer. Other than Perl, some other command or some other programming language, you can still do it. So let's exit out of here and exit out of here again. So now I'm going to create a bash script. Okay, so just copy this and paste it here. So here we got the shell using bash script. So can you use any other programming language like Python, for example? We do have Python 3. So just copy this and paste it right here and hit enter. Enter again. So who am I? Behemoth2. It doesn't matter the programming language you use. Once you understand the concept, it's pretty easy. So I hope you enjoyed this one, and I'll see you guys in the next one. Peace.